All right, number 21. Integral from 0 to pi over 4 cosine squared of theta d theta. Okay, when I look at this problem, the first thing I want to try is is it really easy? The integral of cosine is sine, so does it just have to be the sine squared of theta? And unfortunately, the answer to that is no. It's just not. And if you're not sure and you want to try that out and see, let's just pretend just for a second that the integral was the cosine squared. The integral was the sine squared of theta d theta. Just not d theta. Just take the derivative of what you have. If y did equal that and you found dy dx, you'd have, this is a power rule, 2 sine theta cosine theta, and that would be it, which is clearly not what you started with. So I'm going to delete that for now. So the next thing I want to try is u substitution. And I wasn't sure for a while. I'd think about it, and I'd be like, all right, well, what if u was the cosine of theta? And du would then be negative sine theta d theta. And that would mean d theta was just du over negative sine theta. And once again, I'm just trying things out. Ooh, sine theta. Okay, so if I went back to my problem, I tried all different things. I would try, making this so that, maybe it's u squared. And now d theta is du over negative sine theta. Well, that doesn't help because I still have a sine of theta and there's nothing else to cancel out with, so can't be it. All right, well, then I got smart and I was like, all right, well, maybe, why don't I separate it out? And it's just one of them I'm going to keep as a cosine of theta, and the other one I'm going to make a u. And I'm going to say, all right, d theta over negative, du over negative sine of theta. I'm like, cosine over sine, that's cotangent. But that would be cotangent of theta. And you still would have the problem where you'd have cotangent of theta times u du. And you cannot integrate something that has a variable and not the same dummy variable on the end. So when all else fails, all of that is wrong, there has to be something else. And that's when we're going to use a couple of trig substitutions, which is what we're going to use right here. So we should remember from pre-calc that cosine squared of theta would equal 1/2 times 1 plus cosine of 2 theta. That's just a rule that you learned. So this isn't a u substitution. I'm not taking the derivative of this. I'm just rewriting this as from 0 to pi over 4, 1/2, 1 plus cosine of 2 theta. Now the reason why I want to do this is, well, if I pull through this 1/2, if I pull that out, I'm just looking at 1 plus the cosine of 2 theta, d theta, and that I can integrate. I'm going to have 1/2 times the integral of 1, which is going to be theta, plus the integral of cosine of 2 theta, which we had a rule for. Integral of cosine 2 theta was sine of 2 theta over theta from 0 to pi over 4. And now I can plug in my numbers. I've got 1/2. I'm going to deal with that at the end. Pi over 4 plus sine of pi over 4. Well, 2 times pi over 4 will be pi over 2, and sine of pi over 2 is 1. So this is 1 over theta. Ooh, that was weird. This would not 1 over theta. It's 1 over 2. 1 over 2. I'm sorry about that. Minus, now let me plug in 0. So that would be 0 plus sine of 2 times 0 is still 0 over 2. All right, so let's look at what we have here. We've got 1/2 times pi over 4 plus 1 over 2, which is pi over 8 plus 1 over 4. And that would be option C. All right, next one, 22. It looks like the integral from pi over 12 to pi over 4 of this crazy looking thing. So once again, I'm going to look at it. I'm going to try and think if there's a rule that I could use. In fact, there's lots of different ways that I can integrate this. Okay. One of them is with u substitution. And so with u substitution, I could make u equal to the sine of 2x. So du would be cosine of 2x times 2 dx, which would make dx would be du over 2 cosine of 2x. And hopefully you can see that that's going to cancel it out. Go ahead and write that. Cosine of 2x over u squared, which is what this now is. And this is going to be du over 2 cosine of 2x. Cosine of 2x is cancel. And so switching colors here. This would equal the integral of u to the negative 2 du. And I'm going to change my bounds. I'm going to change my bounds by plugging them into my u. When I plug pi over 12 in here for my u, sine of 2 times pi over 12 is like sine of pi over 6. And sine of pi over 6 is 1/2. When I plug pi over 4 in here, 2 times pi over 4 is pi over 2. And sine of pi over 2 is 1. So now if I were to integrate this, I'm going to integrate really quickly. U to the negative 2 is going to be u to the negative 1 divided by negative 1. So times negative. I forgot my 2 again. Let me pull that through. So I've got 1/2 times this from my new bounds, 1/2 to 1. Okay, this u to the negative 1 is really 1 over u. So I've got negative 1/2 times 1 over 1, which is 1, minus, let me plug in the 1/2. 1 over 1/2 is actually 2. And so negative 1/2 times negative 1 is just positive 1/2. And that is option C. There's lots of ways that you can think about this. Another way that you could think about it altogether differently is that this is the same thing as the cosine of 2x over the sine of 2x times 1 over the sine of 2x. And cosine over sine is cotangent of 2x. And 1 over sine is cosecant of 2x. And there's actually a rule for that we could have used. So that's another way of thinking about this. All right, 23. Let's look at this one. Here I have 2 terms in the numerator, 1 in the denominator. So I'm going to try and separate it. Anytime this happens, you can separate it. So we're going to go the integral from 0 to 1 of e to the negative x over e to the negative x plus, I believe that is, 1 over e to the negative x dx. All right, if we do this, the integral from 0 to 1, this is 1 plus e to the negative x, but in the denominator is e to the x. All right, we can integrate that. The integral of 1 is x. The integral of e to the x is e to the x. And we're doing that from 0 to 1. Let's plug in the 1. We've got 1 plus e to the x, or e to the 1. So 1 plus e. Minus, let's plug in 0 to both of them. 0 plus e to the 0, which is 1. So this becomes 1 plus e minus 1, which is actually just e. And that answer is A.